Hello, this is exam 2 review for Psych 202 Introduction to Psychology, section 1. So we have quite a few questions to go over today, so let's go ahead and start. So the first question was, what is the difference between exemplar view and classical view of concepts? And please give an example of a real life situation. So how do we actually form and learn concepts? So first of all, we think we form concepts by definitions. For example, we define a triangle as an object with 3 sides. We define a dog as something that has fur, barks, wagging its tails at you. So this is a very classical view that believes there are hard rules or criteria that define the concept and determine the category membership. But is this how we actually form concepts? And the answer is actually no. So first of all, draw the dog that you imagine. That is, draw a prototype of a dog. What do you think the most prototypical or typical dog looks like to you? So to me, I have a golden retriever. It might look something like this, or doesn't look quite like this, but similar. So it has fur, it has a long nose, and it's pretty large. But there are other types of dogs. There are puppies that look very different from an adult dog, and there are pugs that doesn't have a long nose and have these really large eyes. They pugs look very different from what a prototypical dog would look like. And there's so many examples. This is, I believe, a Japanese Akiba dog, and this is a poodle, and some other types of dogs. So there are many different dogs that are the same species. They're all dogs, but all of them look very different. So there is no one hard rule or hard rules or criteria that define what a dog is. So here comes the exemplar view of concept. So the exemplar view of concept states that individual uses one specific exemplar of the category in their memory as the mental representation to compare with the new stimuli to conduct categorization. So for example, the first ever dog you saw was a golden retriever, and you would use that as the mental representation of a dog and compare a golden retriever to other dogs and determine whether the new thing or the new animal is a dog or not. And this is why often infants or babies or children miscategorize wolves as dogs, because wolves look very much similar to the mental representation of a dog that we normally store, because most likely the first dogs we see in our life is a prototypical view of a dog that looks like a golden retriever. And then we just compare whatever new dog we encounter to that mental representation. So for example, instead of using a perfect dog or an average dog abstracted from all the dogs you have seen before as the criteria for categorization, you're using one particular dog. In this case, a golden retriever you have seen before to categorize new dogs. So here, like all of these things do not look like a prototypical dog. Like the pug in the lower left corner looks like a loaf of bread. But we all know that when you compare this to a mental representation of a dog, of a golden retriever, you see many similarities. Even though they look very different, you know that it is a dog. All right, so the second question is, are functional fixedness and fixation the same thing, or is fixation a cause leading up to functional fixedness? Neither of those, so they're not the same thing, and it's not really one leading up to another. So functional fixedness is the tendency to get stuck in one way of thinking and an inability to see a problem from a new perspective. And in particular, the fixedness in this case is restricted to the function of the object. And I will explain how this is different from fixation later. And so you have these interpretation blocks to problem solving So for functional fixedness, it involves inability to see that an object can have a function other than its typical one. For example, uh, uh, consider a pencil. You usually use pencil to write, but you can also use it as a ruler when you don't have one. So because it's straight. But oftentimes people are fixed to the only functional use of a pencil, which is to write with, and do not consider its other functional abilities. Um, and the solution is it entails thinking about the possible novel uses of all objects in the problem environment. This is basically thinking out of the box, outside the box. An example would be if you need a screwdriver but don't have one, a dime could be used to serve the purpose of a screwdriver because, well, I mean, if you have a if you need a flat head screwdriver, a dime could potentially be used for that. And these are just all examples of how different objects can be used for not its original purposes, but something new. What about fixation? So the example Dr. Wang gave in class was how can you arrange 6 matches to form 4 equilateral triangles? And people often struggle with this. Unless you know what the answer is, very few people can make use of this, can find the solution of this problem. So the solution to this problem is to actually arrange them in a 3D space instead of a 2D space. So fixation, because we normally use it because how matches are normally used, we typically think them in a 2 dimensions. But when it comes to this question, it requires you to think in 3 dimensions. This has nothing to do with the function of a match, because the function of a match is to basically light a fire. But here we're actually asking you to use matches to form an object. It has nothing to do with its original functions whatsoever. And it's not really asking you to what other functions this match can be used for. It's asking you to use it. It can be anything. It can be toothpicks. It can be like little sticks. It can be anything that's like in this form. It doesn't have to be match. So it has nothing to do with its function. So that's why fixation is different from functional fixedness. In functional fixedness, we're still asking you to use matches to do something because it is a match, but not because we need to use matches to form 4 equilateral triangles. All right. So the third question is, what is the difference between the misinformation effect, source misattribution, for false memory in general? An example of each of these would help. So all of these effects, fallacies, are memory related problems. So let's start with misinformation effect. So here in misinformation effect, we're incorporating misleading information into the memory of an event. And the classical experiment done by Elizabeth Loftus, actually when she was an undergraduate student, was asking participants to describe, to estimate the speed of a collision of 2 cars. And it has many ways of, they asked the participants in many ways. So how fast will the cars going when they hit each other, or how fast will the cars going when they smash into each other. So the only difference in these 2 questions are the words used to describe the collision. One is hit and the other one is smashed. So hit apparently is a much lesser extent to smashed. And as expected, when the question was asked in a way of how fast will the cars going when they hit each other, participants estimated a much lower speed than when they were asked when they smashed into each other. So on the right side, you can see the depiction of the actual accident was not really like bad, but when the question of how fast the cars were going when they smashed into each other, the reported recall was much more like the memory reconstruction on the right side here. So yeah, so the reported recall of the rate of speed depended on how the question was asked. So this is misinformation effect. So the information given to the participants was misinformed. So it's very misleading. So it can be hit, it can be smashed, it can be crashed each other or touch each other. So depending on how the question was asked, you can the effect on your memory reconstruction can be very different. What about source misattribution? So this is an entirely different problem. So there is no misleading questions. So basically, if it was the same experiment, asking about how the car collapsed with each other, it would be how fast were they going, and that's it. There is no misleading information whatsoever. But source misattribution can still occur in that situation, and it occurs when someone does not remember where certain memories come from. For example, um, let's say the participants were shown two sets of collisions. One was the one up top, and the other one is the one on the bottom. And then they were asked to, describe or estimate the speed of how fast the cars were going of the top picture. And they couldn't see the pictures when they were being asked this question, so they have to recall from their memory. There is a chance that they mismemorize or falsely recall the one that's actually on the bottom. So that's source misattribution. They're falsely remembering the top one as the bottom one. So the source, or where the memory come from, is misattributed. So the third one is false memory. So false memory refers to cases in which people remember events differently from the way they happen, or in most dramatic cases, remember events that never happened at all. So back to the car collision example. So now they're only showing the top graph, the depiction of the actual accident, but somehow their memory got interfered or encoded wrongly or whatever, and they couldn't actually remember what actually happened. And when they were asked the question of how fast were the cars going without all the misleading information, they still falsely remembered something that actually did not happen. They probably remembered something like the bottom one, even though the bottom one wasn't shown to them. So that's false memory. So that's the difference between the three types of memory failure, reconstruction failure. All right, so next question is, what is an example of using Lewis-Thurstone's factor analysis? So Lewis-Thurstone's factor analysis, so the basic concept here is that first, Lewis-Thurstone tested a bunch of people's cognitive abilities, and then he used this statistical analysis method called factor analysis and derived that there are 7 factors that's related to mental abilities. So spatial visualization, verbal comprehension, reasoning, perceptual speed, numerical ability, word fluency, and associative memory. So these factors are derived from the variables this Lewis collected from the experiment. It really depends on how the experiment was constructed. For example, maybe this experiment did not really involve any kind of auditory comprehension, like playing music or playing certain tones. If he had used that as one of the tasks, maybe he could derive one more factor of auditory ability, or whatever that is. Um, so I'm not going to go into detail of how factor analysis is done. You only need to know that factor analysis is a statistical technique used in experiments that's trying to determine what is kind of like determining factor in a certain set of tasks and what kind of cognitive or mental abilities is being used in these experiments. All right. So next one is questions about the four types of validity. So validity relates to whether you're measuring what you think you're measuring. For example, intelligence tests, are you actually measuring intelligence or are you measuring something else? For example, if I say that go on a scale, like measure your weight is your intelligence. That's apparently wrong. But people design intelligence tests to that has high validity. And there are four different types of validity. The first one is the construct validity. So this is the all-encompassing validity. So it's asking whether a measure actually reflects the intended construct. And the construct here basically refers to the theory underlying the target. For things like height, weight, that's readily observable. It's really easy. Like you go onto a scale, you can measure a weight. That's very easy. But things more psychological, like anxiety, pain, personality. That's my theory. More things that are more psychological, like anxiety, pain, intelligence, or personality. Those things are very abstract, and you don't really have a readily observable measurement that can be used to measure these things. Like let's take intelligence as an example. There are many different intelligence tests on the market right now, and the construct basically refers to what scientists think it, intelligence is. And if the test is capturing that, then we say that it has a construct validity. But how do we know that there is a construct validity? That is criterion validity. So we use criterion validity to support construct validity. So criterion validity, also called predictive validity. Can you use the results of a test, like an intelligence test, to predict a person's achievement in academia, in work, or in life in general? And the assessment device relates to other manifestations to qualify it's supposed to measure. So the other manifestations here basically is, are you successful in school if you have a high intelligence? Are you going to suffer in classes or struggle in classes if you have a low intelligence score or intelligence quotient? So that's the criterion of validity, and it's the most important way to support construct validity. And what are the best criteria to evaluate the predictability of the skill? Intelligence, for example, would be like performance in school, performance at work, or even socioeconomic status, or how much you earn, those kind of things, like how people define successful, because people relate intelligence to success somehow. And then there's the convergent slash discriminant validity. So those are kind of like the opposite side of the mirror. So convergent validity it measures relates to is measures that are related to characteristics similar to what it's supposed to measure. For example, in intelligence tests, we often test for cognitive abilities, like mental rotation, constructing patterns from blocks, or repeating back numbers, those kind of things. You test cognitive abilities. And because we think, or scientists think, intelligence are related to cognitive abilities. And we don't really test your personalities. We don't really test the big five when we talk about intelligence. because we think that personality and intelligence do not share any similar characteristics. So that's conversion validity. And then there's the discriminant validity. So it's measures that do not correlate with what it's not supposed to measure. So that's the personality part. So personality does not correlate with intelligence. So we do not include that in the measurement. All right, so what other skills can be used to support conversion slash discriminant validity of intelligence? So emotional intelligence, well, it really depends on what kind of intelligence you're talking about, right? So if you're talking about the G factor intelligence, so emotional intelligence basically has no correlation with it. But when you are talking about like socioeconomic status, that has a lot to do with intelligence. There is a pretty high correlation between performance in school and intelligence. And a good performance in school often results in a good job. A good job often results in good salary. So good salary increases your socioeconomic status. So there is a correlation between socioeconomic status and intelligence, but it's I wouldn't say it's causal, no. And then the last validity is face validity. So this is the most simple, I guess, simple one to understand. So its assessment device simply appears to measure what it's supposed to measure. Um, like cognitive abilities, like just even by face value, we think, okay, cognitive abilities maybe is testing intelligence. Uh, like putting yourself on a scale and measure a weight, your weight probably does not measure intelligence. So that's kind of like face validity. Does it appear to be measuring what you're trying to measure? Um, so these are the measures that may be easier to respond to. You can get very complicated in measuring certain abilities. In cognitive abilities, there are many tasks, and each of them are measuring a different aspect of your cognitive ability. Some of them are very easy and has a high face validity, and some of them are very complex, and it's not really necessary. It has a very low face validity, and it's not really necessary to include that in an intelligence test because it can be detrimental when constructing embarrassing or threatening. Okay. All right, so next question is, which is more effective, I guess? Delay conditioning or trace conditioning? So, all right, let's talk about what these two are first. So delayed conditioning is conditioned stimulus precedes the unconditioned stimulus and remain present until after the unconditioned stimulus is present so that the two stimuli occur together. Let's take Pavlov's dog as an example. So the conditioned stimulus here is dog food. Unconditioned stimulus here is the bell run. Wait, hold on a second. No. The conditioned stimulus is the bell ring, and the unconditioned stimulus is the dog food. So so this is actually how Pavlov done his experiment. So he run the bell continuously, and while the bell is being run, the dog was presented with food. So the dog can easily pair bell ring with food. And then there's trace conditioning. So instead of presenting the unconditional stimulus and conditional stimulus uh, concurrently, the conditioned stimulus is presented first. So the bell is rung first, and then after the bell is stopped, and after some period of delay, the dog food is presented to the dog. So that's trace conditioning. Um, So which one is more effective? It's actually the delay conditioning is more effective. So the upper panel, delay conditioning is more effective. All right, next one is instinctual drift. So instinctual drift, it relates to classical conditioning apparently. So it's a tendency of an animal to drift back from learned operant response to an object to an innate instinctual response. It involves biological instinctual responses that sometimes limit or hinder ability to condition other less natural responses, and suggests organisms will learn certain associations more easily than others. So take, again, dogs as an example. So if you have a dog, you know that training the dog to restrain themselves from eating food is very difficult to train. I've tried that on my dog, and it did not go well at first. So the instinct of dogs or of any animal is to eat. So it's opposing or it's against its instinctual response to food if you ask them not to eat it. And even if you've trained them to perform this task of not eating the food, like saying hold or stay, those kind of things, if you don't reinforce or reconsolidate this behavior over time, there will be instinctual drift that they will unlearn or they will forget what they learned from hold or stay. They will start to disobey your orders. And the last point, which suggests organisms will learn certain associations more easily than others. So training a dog to not eat food can be difficult. But if you're training something like come here, if you pair that command with a piece of trait, they will very easily learn this association. So when they hear that come here and you have food in your hand, they know that, okay, you want me to come to you. So this is a very easy association to learn because they want to eat the treat. All right, next question. What was the experimental dissociation between the amnesia patient and healthy people in the word completion task? So the original slide was this. Actually, the numbers were wrong. I looked it up. The actual numbers are this. So the controls and the amnesic ones are flipped. So in the original experiment, they tested for several methods of memory recall. So there were free recall, so asking a question and you just spits out things that you memorized, or recognition, choosing the ones that you feel familiar. And then there's the fragmented words. So basically, the words are erased in parts, and you have to complete it to a full word. And in free recall and recognition, those two tasks are associated with explicit memory. So in those cases, control participants, so healthy participants, were doing much better than amnesic patients. So amnesic patients for free recall was doing 8, some kind of measurement, and control was doing 13, so 13 is better. For recognition, control is still better than amnesic patients. But when it comes to fragmented words, the control group and the amnesic group are basically doing the same. They're within the 11-ish range. So this means fragmented words, the word completion task, is actually using a different memory system. So this is kind of like a dissociation between explicit memory and implicit memory. So free recall recognition, we know it uses explicit memory. And for word completion task, since control and amnesic patients are doing similarly, we know that it's using a different memory system, which is implicit memory. All right, next question. How does the rational choice theory differ from expected utility theory? All right, so decision making, rational and otherwise. So, rational choice theory. It is a view that people behave as they do because they believe that performing their chosen action has more benefits than costs. And I'll put this into an example in the next slide. So, let's take a look at the expected utility theory first. So value of a decision equals to expected utility of making an action A, where the expectation or average is carried out over the possible outcomes of that action. So it has maximum expected utility. For example, the one that we saw in class was that A, you have a 70% chance winning $4,000, B, 80% chance winning $3,000. So if you're using the expected utility theory, you should calculate the expected utility first. So expected utility for A is 4,000 times 0.7, so 70% equals 2,800. So the expected utility of choice A is 2,800. And for B is 3,000 times 0.8, which is 2,400. So we can see here the expected utility of A is higher than B. So if we're behaving in a way that's similar, that corresponds to expected utility theory, we should choose A. But in fact, let's look back at rational choice theory. It's a view that people behave as they do because they believe that performing their chosen action has more benefits than costs. So here, if you're using the rational choice theory, like for me, I personally think that maybe I will get unlucky and 70% chance is not a very high chance. I'd rather take less money for a higher chance of winning. I would choose B because I think that choosing B has a higher benefit than cost if I'm choosing according to rational choice theory. So these two are different. So expected utility is always choosing the one that has the highest utility, but the rational choice theory, you behave as you think that's fit. You think which one is better for you, not because it has a better utility. All right, next one. What does economic man mean? So economic man refers to an idealized human being who acts rationally and with complete knowledge, who seeks to maximize personal utility or satisfaction. Economic man is an assumption of many economic models and is also known as a homo economicus. So it does not exist. No human being has complete knowledge, and no human being acts completely rationally. So this is kind of like a problem in experiments, especially in experiments such as economy or physics. So they oftentimes, or even in psychology, they oftentimes build an ideal model. What would an ideal observer mean? So there, in psychology, there is an ideal observer in cognitive psychology. Basically, refers to what would an ideal human being not making any mistakes do on a task. Oftentimes, given the constraints of the perceptual system or cognitive abilities, like for example, if you're doing a discrimination task, the correct rate will not be 100%, but it will be very close. It's idealized. That raises certain problems, especially in economic models and physics. In physics, like you have a perfect spherical ball that has zero friction that does not exist in this world. So it's idealized. So it's the same thing with economic man. This idealized human that acts rationally and with complete knowledge simply does not exist in this world. All right, next up is four-card selection test, which is related to confirmation bias. So let's talk about confirmation bias first. So confirmation bias is the tendency to seek evidence that confirms one's beliefs. Natural tendency, if I'm right, then fact C will confirm my theory. I must look for fact C. Scientific practice, if I'm right, then fact D will disprove or at least disconfirm my theory. I must search for fact. So the natural tendency is what the confirmation bias is. The scientific practice is going against confirmation bias. We have to find something that disconfirms my theory. All right, so let's take an example. So right now, the coronavirus thing is huge, and I personally think Trump is not really doing a good job um, containing the virus, and certain actions from him is outrageous and racist. So I would actually, when I'm Googling news or looking at news uh, regarding coronavirus, I will actually try to look for news that discredit Trump in some way. I would not find news that actually speaks to that Trump is actually doing a job, which I don't think so. But coming back to the 4-card selection task. So the 4 card below, so you have an A, you have a K, you have 4, and you have 7. So each of the card below have information on both sides. So you're only showing one side of them. So on one side of a card is a letter, and on the other side is a number. And consider this rule. If a card has a vowel on one side, then it has an even number on the other side. And you have to select the card or cards that you definitely must turn over to determine whether the rule is true or false for these 4 cards. And naturally, you would say, okay, I'm going to flip over A and flip over 4 to confirm that behind A there is indeed an even number, and behind 4 there is indeed a vowel. And that you're actually falling to confirmation bias. You're only confirming this rule. You're confirming that, okay, if it has a vowel on one side, then it has an even number on the other side. You're not disconfirming it. You're not trying to disprove this rule. To disprove this rule, you actually need to flip over 7. So if you flip over 7 and find out that there isn't vowel on the other side, then it means the rule is wrong. If you flip over 7 and it's not a vowel on the other side, then it means, okay, this rule is still holding true. The only card you don't really have to flip over, I think, is K, because it's not a vowel on this side, so it doesn't really matter what number is on the other side, because the rule says if a card has a vowel on the other side, then it has an even number, but it doesn't say that only vowel has an even number on the other side. So confirmation bias, people only flip A and 4, but not 7. All right, so that's all of the questions for exam 2 review.